Hey guys, okay, so here's the next subunit here, and what we're gonna do is we're gonna focus on naming compounds. All right. So in the last video, we talked about forming compounds. Now we're going to name them. All right. Take a look at this little graphic here, and this kind of breaks it down for you. So we already said that the metal in a cation is the metal, excuse me, and the non-metal is the anion. So here's what happens. When barium oxidizes, okay, it forms a barium ion. I want you guys to notice that the name of the metal does not change, okay? So you form a barium ion. When the non-metal forms an ion, you form what we call the chloride ion. I want you to pay attention to the suffix, the chloride ion. So all nonmetals are going to get this IDE ending, okay, when they form an ion. So to properly name a compound, you take your barium ion and your chloride ion, you remove the word ion, okay, and you end up with barium chloride. This is the name of the ionic compound, okay? So rule number one is that the metal keeps its name. Always keeps its name, keeps name. Whatever the name is on the periodic table, that's what you call it. The anion, or the nonmetal, okay, that gets the IDE ending added to it. Adds the IDE ending, okay, the suffix. Okay, then you combine. So I'm going to give you an example here of how this works. I know I'm going to take an example of calcium. You know what? I got to stop using these. I got to stop using C's because this don't always does this to me. Let me see here. All right, let's do potassium. Oops. So potassium, and let's do sulfur. Okay, so potassium and sulfur. So when these ionize, they form the compound that is neutral, that is potassium and sulfur. Okay, if you don't know how I came up with these, feel free to go back and rewatch the other video, but I can see here that this one's going to make a +1, the sulfur is going to make a -2, and those ions combine to form this compound. Now, according to the rules, if I want to name this, the ions that form here are the potassium ion, right? And the sulfide ion. I remove the ion, okay, and this makes potassium sulfide. Okay, so when you're naming an ionic compound, understand that the nonmetal is always going to get that IDE suffix, always. Okay, I'm not going to harken you guys too much on your spelling, like if you don't know exactly which letters to drop, because they're all going to be different. But just understand that it's going to form an IDE ion. Okay. All right, I'm going to scroll up a little bit here. Okay, here's where it gets a little bit trickier, but yet at the same time, it's a little bit easier. These guys here, the ones that I'm going to underline, okay, if you're my pre-AP students, you should already know that these are polyatomic ions. For others that are not my pre-AP students, for my general chemistry classes, these are ions that are formed with with two or more non-metals, okay? So both of these elements that are going to be in this polyatomic ion are going to be non-metals, but because the way that they're set up, they do carry an ionic charge, okay? So because they carry an ionic charge, they're going to form ionic compounds. So I want you guys to think of this as like your non-metal, and this is your metal, okay? Even though there's more than one atom, just think of it as a single element because that's going to make your lives way easier. For my pre-AP students, you should understand that these are your polyatomic ions, and this is why you need to know them. You will have a list coming to you of all these elements, of all these ions, so you can refer back to them. But my pre-AP students should understand that they need to memorize these, right? At least learn them, the 25 most common. Now, how do you name these compounds? Well, When you're talking about a polyatomic ion, okay, a polyatomic ion is something like this, sulfate, right? This has a common name. So when you're naming these guys, all right, whatever the common name is, that's what you're going to call it. The PO4, for example, is called phosphate. Okay, the LH, this is hydroxide. Okay, and the NO3 is nitrate. So as you learn these, okay, or you use your table reference, here's how you name it. The metal always keeps its name just like it does in regular ionic compounds. Whatever the name is on the periodic table, that's what you're going to keep. The polyatomic ion has its own name. It's going to have a common name. So for example, the ones that I just named, sulfate, phosphate, and hydroxide, nitrate, you're just going to keep those names exactly as they are. So if we're going to name this guy, for example, right, that we'll name him number 1, then the name for this compound would be sodium. And then it's bonded to hydroxide, so it's going to be sodium hydroxide. Okay, sodium hydroxide. If we name this guy number 2 here, this guy's going to be called sodium. Metal always keeps its name. And whatever the common name is, so this guy's going to be called sodium nitrate. I want you guys to see that there's no IDE ending. IDE ending only comes to those single atoms that ionize. When you have a polyatomic ion, whatever the name is how you name it. We'll call this guy number 3. To name this guy, you take the name of the metal, which is aluminum. And then whatever the ion it's bonded to, you use its common name, sulfate. So this will be called aluminum sulfate, okay? So understand that you should have a list in your notebook going forward that you can refer back to, but you need to understand when it is that you're looking at a polyatomic ion. So I want you guys, even though you don't have to learn them in my general chemistry class, I want you guys to take a look over them and make sure that you at least recognize them so you can go to your table and look. For my pre-AP students, you already know you got to learn these. So just practice, okay? Practice, 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 and study. All right. Last one is when we're using transition metals, okay? So here's an example of all D block elements that are transition metals, chromium, cobalt, copper. The reason these are called transition metals is because you can see that they don't just form one ion, they form multiple ions. So copper, for example, has at least 2 different oxidation states, the most common that it can form. It can form a +1 or it can form a +2. Now, because these guys have different oxidation states, you have to let me know which one it is that you're working with. For example, if you're creating a compound with copper 1, then you have to name it copper 1, including a Roman numeral, okay? If the compound you're working with is copper 2, then you have to include the 2 in the Roman numeral. For my pre-AP students, you have to understand the trivial name, the common name, which is cuprous for 1 and cupric for 2. When it comes to transition metals, the one that has the higher oxidation state is going to have the IC ending. The one with the lower oxidation state, for example, here is going to have the OUS ending, okay? So for my pre-AP students, you have to know both. For those in my general chemistry class that want to challenge themselves a little bit, please feel free to take a look at those also, okay? You're going to have different questions on different sets of assignments that are going to include both. And this is just another way to challenge yourself if you want to, all right? So let's do an example. Let's do an example. Let's say I'm going to do lead, right? Lead can either form a 2+ or lead can form a 4+. Right? These are the 2 charges or oxidation states that lead can form. So let's bond it to chlorine, right? So if I bond this to chlorine, right, this is what the compound looks like. Here, and then here. Okay, it's going to have 2 different compounds. Okay, now if I'm going to name this guy with the rules, okay, so we'll call this one number 1 and number 2. So number 1, this would be either lead 2 chloride, remember, because it's a single atom that ionizes, lead 2 chloride, or plumous chloride. okay? For number 2, this would be lead. This is number 2, yeah. Lead 4 chloride or plumic. Plumic chloride. And knowing these, you got to be able to identify which one is the 4 and the 2. Remember, the one with the greater oxidation state is going to have the IC ending, okay? This would be the same if we were using polyatomic ions. Let's say we're going to do copper, right? Copper 1+ or copper 2+ bonds with sulfate, right? So the compounds would be as follows. This would be Cu2SO4, right? Because this guy carries a -2. Or this would be CuSO4. Since they're both +2 and -2, they cancel each other out. What would you call these guys? Number 1, let's call this guy number 1 and number 2. Number 1 would be called copper 1 sulfate, okay? Or cuprous sulfate. And number 2 would be copper 2 sulfate. Right, there it goes again. Copper 2 sulfate. Or cupric sulfate. Okay. All right, guys. This is pretty much the gist of how to name compounds. Remember that when you're working with the transition metal, you have to use either the common name or the systematic name with the Roman numerals. Understand that polyatomic ions are going to be used whatever name they're named, okay? And then you always add the IDE ending if it's just a single atom that's been ionized, okay, to form an anion. All right, guys, I'm going to go ahead and stop the video here. Remember, you can always ask me questions, and good luck. Thank you.